the protein in red blood cells that carries oxygen from the lungs to body tissues. So people with fewer than 12 milligrams of hemoglobin per deciliter of blood are anemic. A public health official in Jordan suspects that the Jordanian children are at risk of anemia. He measures a random sample of 50 children and gets a sample of 11.3 milligrams per deciliter with a standard deviation of 1.6. We're going to carry out a one-sample t-test. First, we need to recognize that this is quantitative, so our mean is mu and our statistic is x bar. So we're going to work under the assumption that mu is equal to 12. If mu is equal to 12, that is the mean level of hemoglobin for children in Jordania. Our alternate hypothesis is that the mean level is actually less than 12 milligrams per deciliter for hemoglobin in Jordanian children. Make sure you do write out what your variable is, whether you write out the null hypothesis or write it out in words to the side of the null hypothesis. Also include that the significance level is 5%. That concludes the state portion of your hypothesis test. Now we need to go to the plan portion. We want to do a one sample t-test, so there are things that we have to check. So I'm going to write, with conditions met, I'm going to conduct a one sample t-test. Well, I need independence and I need normality in order to do this. So how do I have independence? I state that there's a random sample, which there was, and then I can also throw in that 50 is less than 10% of all Jordanian children. And then to check that there's a nearly normal or a t-distribution, we're going to use the central limit theorem here. Our sample size is greater than or equal to 30, so the central limit theorem says that we can use an approximately normal curve. Moving on to the do portion. So we're going to be working on a t-distribution, and we're working under the assumption that mu is 12. Our degrees of freedom is n minus 1. So if we take 50 and subtract 1, we're working with the degrees of freedom 49. You need to write that on your paper on an FRQ. So now we calculate standard deviation. In this case, we don't have sigma, so we're going to calculate standard error. S of x from our sample is 1.6 divided by the square root of n. That's approximately 0.2263 milligrams per deciliter. And then shade in our region. We're looking for 11.3 or more extreme. That's what our sample was, 11.3 for these 50 Jordanian children. Calculate your test statistic. Statistic minus the parameter 11.3 minus 12 divided by your standard error gave me a test statistic of negative 3.09. I'm going to sketch that on my curve. Centered around 0, I have a test statistic of negative 3.09. Now I need to find out what the p-value is that connects to that test statistic. So what's the probability that I would get a sample of 11.3 or less given my true mean is 12, given the null is true? That's the same as calculating the area under the curve left of a t-value of negative 3.09. So I'm going to do TCDF, area under the curve, TCDF, lower bound negative infinity, upper bound negative 3.09, degrees of freedom 49, press enter, and I get a t-value or a p-value of about 0.165%, so less than 0.5%. So another way I could have done this in the calculator is by doing a t-test. In my t-test, I'm going to enter my information. My null hypothesis was 12. My sample had an average of 11.3. My standard deviation was 1.6. My sample size was 50. My alternate hypothesis had a less than sign. So I put that into the calculator and I get the same information. So what does this all mean? What's our conclusion? Well, if the null hypothesis is true, that the mean is 12 milligrams per deciliter, then we would obtain a sample of 0.615% for 50 Jordanian, we would attain our sample 11.3 milligrams per deciliter, 0.165% chance of the time. This is how you interpret the p-value. This is the probability of obtaining your sample if the null hypothesis is true. So do we have significant evidence? Yes. Since the p-value is so low, less than alpha, we can reject our null hypothesis that the Jordanian children are in the safe zone of 12 milligrams per deciliter of hemoglobin in their blood. We have significant evidence to believe that the Jordanian children are anemic.